We're going to go over an example of computation of azimuths for a closed polygon. First thing we want to do is remember that when you're talking about polygons, if it's a closed polygon, you have a theory that says the number of angles minus 2 times 180 degrees is going to give you the theoretical total of the interior angles. So in this one, I have 6 angles. So 6 minus 2 times 180 is going to give me 720 degrees. So when I add up each of these interior angles, then it should give me 720 degrees, and it does. So you should always check to make sure that your polygon closes. For example, specifically when we go to do the traverse project. Now, the other thing that this example gives us is a start point. It gives us a bearing of northeast, north 45 degrees, 35 minutes east. So the process that we're going to be using is we're going to figure out an azimuth. We're going to determine our back azimuth. And then we're going to add an angle to get a new azimuth. So as we're talking about this, step 1 is determine azimuth. Step 2, determine the back azimuth. Step 3, add an angle. Step 4 gets us back to an azimuth again. So first thing we need to do is figure out what our azimuth is of the given information, given bearing. So the bearing is in the northeast quadrant, so we know that when a bearing is in the northeast quadrant, it's going to be the same as the azimuth. So what we need now is the back azimuth. So we're going from B to A. So A to B was 45, 35. We want B to A. So we said if the azimuth is less than 180, we add 180. So this angle here from 0 degrees out is going to be 225, 35. So that's our azimuth from B to A. And it helps to write out the first letter being the direction you're starting at, and the second letter is where you're going. Okay? Now, here's our polygon. We know we're 45, 35 is our start direction. So what we're going to do is we have an azimuth, we get a back azimuth, and we're going to add an angle to get a new azimuth. So azimuth, back azimuth, add an angle. That's a little symbol for angle. So we had 225 degrees and 35 minutes to here. So if I drew the picture up here, it might be a little easier to see. From north, we got 225. Oops, I messed that up. Let me clear that up. I use a thinner pen. So from the north, we're going to here, 225 degrees, 35 minutes. And then we're going to add 34 degrees, 30 minutes to get this angle. So looking at this picture here, 225 plus 130 is going to give us, it goes all the way past and gives us 360 degrees in 5 minutes. We know that we're only going to use 360, so we're going to subtract out, and that's going to give us an azimuth from B to C as 5 minutes. Now, we're going to look at the bearings at each one as we go along. And since we know when an azimuth is in the first quadrant, it's going to have the same angle as the bearing. So we just have to put on north and east. So north 0 degrees, 5 minutes east. The next thing we're going to do is we're going to move up to C. So now we're up here. So we need to get the back azimuth from C to B. So this was the azimuth from B to C. We're going to add 180 degrees to get the back azimuth of C to B, which is going to be 180 degrees plus 5 is going to be 180 degrees 5 minutes. And then we're going to add the angle at C to give us the new azimuth of C to D, which is 272 degrees and 40 minutes. Okay, so now from C to D, we've got 272.40. This being in the, if I look at this being in the fourth quadrant, then I'm going to take 360 degrees and subtract out the 272.40, which tells me that I have an angle in here of north 87 degrees 20 minutes west. So again, I'm going to repeat the pattern. I have an azimuth, I get a back azimuth, I add an angle to get a new azimuth. So now we know that this azimuth from C to D is 272 degrees and 40 minutes. The purpose of all of this is we're going to be using azimuths to figure out coordinates for each of our points in the future lecture. So now that we're going to move to D, we know from C to D we have 272. So remember, we have an azimuth. We have to go, all right, we have 272 degrees 40 minutes is our azimuth. It's greater than 180 degrees, so we have to subtract 180 degrees to get our back azimuth from D to C. So if I draw my picture up over here, from C to D is 272, and D to C, the back azimuth is going to be 92 degrees 40 minutes. Once we find the back azimuth, we're going to add the angle at D, the 127 degrees 11 minutes, and we're going to get a new azimuth from D to E, which is to here. So that's 219 degrees and 51 minutes. Now, the bearing, if this is 219.51 from here to here, we know that from here to here is 180. So for us to figure out what this angle is in the southwest direction, we're going to take the 219.51 and subtract 180. So that's going to be south 39.51 west. Now we're going to E. So we need the back azimuth from E to D. We know that the azimuth from D to E is 219. Since 219 is greater than 180, we're going to subtract and get our back azimuth of 39. So this is 39 degrees and 51 minutes. Once we do that, we're going to add our angle, and we're going to get a new azimuth. So azimuth, back azimuth, add an angle. So back azimuth was, azimuth was 219, back azimuth is 39, and adding the angle of 115 degrees is going to give us a new azimuth going from E to F as 152. So let me clear that up. So the azimuth going from here to here is going to be 155 degrees in 2 minutes. Now, with that being said, we will need to look at what this is 155 to, we want to know what this angle is. That's going to be, we know the entire thing here is 180, so we're going to take 180 minus the 152, and it's going to give us this angle here of south 24 degrees 58 minutes east. Now we're sitting at F, and we need the back azimuth, F to E. So we have our azimuth from E to F as 152. We're going to add 180 because it's 155 degrees 2 minutes. We'll add 180, and that's going to give us a back azimuth of 335 degrees and 2 minutes. Then we're going to add the angle of 115.51 to get the new azimuth from F to A. So when we look at this, azimuth, back azimuth, add an angle. Now when we do that, we get 450 degrees and 53 minutes. So we're going to subtract off 360, and it's going to give us 90 degrees and 53 minutes. So if I drew an origin mark from here to here, is going to be 90 degrees and 53 minutes. Well, that tells me I'm actually in a little less than, this isn't drawn properly, I'm a little lower than 90 degrees. So we know that bearings can't be greater than 90, so I know I'm actually in the second quadrant. So this line is going a little bit southeast. Okay, so I'm going to take 180 minus 90 degrees 53, and that's going to give me south 89 degrees 7 minutes east. Now, from F to A, so our next one is, I'm sitting at A, and my azimuth from F to A is 90 degrees, 53 minutes. So it's less than 180, so I'm going to add 180 to get my back azimuth A to F, which is now going to be 270 degrees and 53 minutes. And then I'm going to add my angle, which is the 134.42, and that's going to give me 405 degrees and 35 minutes. We know it's greater than a 360, so we're going to subtract 360, and it's going to give us the 45 degrees and 35 minutes that we started with. That's the good thing about survey, is there's always a check, or there's almost always a check. So the 45 degrees, 35 minutes matches what we started over here of the 45 degrees and 35 minutes. So this is the example that's similar to the homework. So now I'm going to show you how to do it in a different way. We're going to do it in a table format. We have the north 45 degrees, 35 minutes east, and we're going to convert that into an azimuth like we did before. So since it's in the first quadrant, we know the azimuth is the same as the bearing angle. So what we're going to do is calculate our azimuths. We're going to start with the azimuth of the known, the 45 degrees, 35 minutes. Remember, we're going to get an azimuth, we're going to take its back azimuth, and then we're going to add an angle, okay? Then that's going to give us an azimuth. We're going to get a back azimuth, and then we're going to add an angle. Remember, the back azimuth, if the azimuth is less than 180 degrees, then we're going to add 180 degrees. If the azimuth, and that's to get the back azimuth. But if the azimuth is greater than 180 degrees, then we're going to subtract 180 degrees to get the back azimuth. So here's the process. Here's our azimuth. It's less than 180, so we're going to add 180 to get the back azimuth. So it's going from A to B, now it's B to A is the back azimuth. Add an angle. We're going to add the angle at B. Okay, so we're going to get the azimuth from B to C is 360 degrees in 5 minutes. We know that can't be greater. Typically, we don't work with anything greater than 360, so we're going to subtract 360. So our azimuth from B to C, from here to here, is the 5 minutes. It's less than 180, so we're going to add 180 to get the back azimuth from C to B. We're going to add the angle and get an azimuth from C to D. It's greater than 180, so we're going to subtract 180 to get the back azimuth from D to C. We're going to add the angle at D, and we're going to get the azimuth from D to E. Now, it's greater than 180, so we're going to subtract 180 degrees, and then we're going to get the back azimuth from E to D. We're going to add the angle at E to get the azimuth from E to F. We're going to add 180 because the azimuth is less than 180 to get the back azimuth of 335, and we're going to add the angle at F. We'll have when we get the azimuth from F to A is 450 degrees. That's greater than 360, so our azimuth from F to A is 90 degrees and 53 minutes. The azimuth from F to A is less than 180, so we're going to add 180 to get the back azimuth of A to F. We're going to add the angle at A, and then we'll get the azimuth from A to B. Now we have a known azimuth from A to B from here at the top, which is 4535. Well, we know that we can't have greater than 360, so we're going to subtract 360, and these two numbers need to check. When we do this completely all the way around, the final check is the azimuth that we started with gives us the azimuth we end with. So this is how we'll do it in table format. Remember, it's azimuth, back azimuth, add the angle. Okay? Azimuth, back azimuth, add an angle, get a new azimuth. All right, that's it.